Hello and welcome to Chapter 5. Chapter 5 is called Linear Functions. Linear means drawing a line. Function means finding the rule. So we're going to do a lot of graphing in this section. So we're going to be doing a lot of graphing in this chapter. The first section is called Identifying Linear Functions. So we're going to go through a little vocabulary. A linear function is a function whose graph forms a straight line, and each x has only one y. The rule, when you put an x in, can give you only one y in order for it to be considered a linear function. So, if an x, here's a good example of each x, each little point that you give on this x-axis will only give you one y, and those points are all found along that line. Now, even this one, each x will only give you one y. Where is that not true when you have a straight line? Well, that's here. If I give you this x, it will give you all these kind of y's. If you have a completely vertical line, that is not considered a linear function because one x can give more than one y. Every other straight line has a linear function. Now, we've talked about tables before. You can tell there's a linear function when there is a constant change. When the x's, if you've got a constant change in your x's, you've also got a constant change in your y's. If this happens but this doesn't happen, it's not a function. So that's one quick way to notice without having to graph all of the points. And this information will get you through the first two check it outs. So please pause the video here, do check it out numbers 1 and 2 on pages 300 and 301. Pause the video and come back when you're done. Check it out number 1 just asks you to look at the pictures and tell me, is it a function or is it not a function? The first one is, the second one is, the third one is not, because there are some x's that will give you two y's. The second check it out just gives you a table, just gives you a set of points and asks you if it's a function. You don't have to work anything out. Just make yourself a table so you can see that, yes, there are constant changes. That makes a linear function. This will graph into a line. Using linear equations and graphing functions. A linear equation is any equation that represents a line. It can be written in standard form. Now, standard form is ax plus by equals c, where a, b, and c are real numbers. Real numbers means positive or negative. They mean whole numbers or parts of numbers where you've got decimals or fractions or mixed numbers. Those are all possibilities. It could also be 0, but not for a and b both. These both can't be 0. 0 equals c is not a linear function, but one of the two of these can be. C can be, but not both of these. A linear function is written y equals mx plus b, where x and b are real numbers, which is just numbers. This is the rule that's going to graph our line. Actually getting it into this format is going to help us graph our line. We're going to go into exactly we're going to go into the details of this particular type of form. We're going to go into the particulars of this particular form of equation a couple of sections from now. But for the most part, this version is going to be your friend. So the question for this section, tell whether each function is linear, and if so, graph. So we've got two sample equations here, y equals x plus 3. The first thing we're going to do is try and write it in standard form. Standard form, remember, is ax plus by equals c. And if I can write it in this form, and there are no exponents of x or y, then I know that it is a linear function. So I want the constant, because there's no x's or y's on c, I want the constant to be by itself. I'm going to subtract x from both sides. So I'm going to get negative x plus y equals 3. This is standard form, and that means yes. It is a linear function, so I can graph it. So when I graph, I'm going to make my XY chart. And it's x plus 3 and y. And if I say my x is -1, 0, and 1, -1 plus 3 is 2, 3, and 4. So, -1, 2, and 0, 3, and 1, 4. Ta-da! It's graphable. Y equals x squared. X squared is not found in standard form. We're not going to be able to rewrite this into standard form at all, so this is not a linear function. Next, we have word problems. On page 303, Sue rents a manicure station in a salon and pays the salon owner $5.50 for each manicure she gives. $5.50 per manicure. The amount Sue pays each day is given by the function f of x is how many manicures she does times 5.5. How many manicures she does, x times 5.5, where x is the number of manicures. Notice I have to define my variable. This is what that means. Just doing this means you've defined your variable. What does x stand for? So, we're going to graph this function and give its domain. We're going to graph this function, give its domain and its range. Now we know that we can't have -2 manicures. This is real life. So we're just going to use the first quadrant of the coordinate plane. And we know that for any x that we stick in, it's 5.5 times x, which is going to give us our y. So if we start with x, y is going to be 0 when x is 0. If I don't make any money, I don't have any money. 5.5, 2 is going to be 11, 3 is going to be 16.5. So I'm going to start here and I'm going to go up like this. And that's my graph. What's my domain? Here's my domain, here's my range. This should get you through check it out number 4, so you know that you are comfortable with word problems. Please pause here, try that problem, and come back. Please pause here, try number 4 and number 3, and come back when you're done. Check it out number 3. 3a, we have y equals 5x minus 9. I'm going to put it in standard form. So yes, we've determined that it is a linear function. I'm going to give it 5 x's. That'll give me 5 y's, and I'm going to graph it. It looks like this. (3b) y equals 12. This is a no. A is 0. What is A? Anytime y equals just one number, the line that it graphs is going to be the line where y equals 12. Y equals 12. Doesn't matter what x equals. Y equals 12. This is that line. But any x that we put in here, all are going to point to 1y, so the x's don't matter. So this is not a linear function. 3c, again, we've got 2 to the x power. We can't put this into standard form. So while this is an equation, it's not a linear function. Now, if you're interested in it, when you have a negative x in your, nope. And for those of you who are interested and want to take it to the next level, if you've got a negative number in your exponent, what that means is this same thing, but on the denominator. So 2 to the negative 1 is the same as 1 over 2 to the 1. And 2 to the negative 5 is the same as 1 over 2 to the 5, which is, 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, which is the same as 1 over 32. But you didn't need to know that. That's just if you're interested. Number 4. We rent the station for $10 a day and we give $3 manicures. The amount that she would pay, the function of x, is 3 times the number of manicures plus $10. And I have to define x as the number of manicures. So I make myself a chart labeling the domain and the range. And I started with a regular graph, but x can't be negative, so we're only going to start here and it's going to go up. So your homework for this section is going to start on page 304, and you're going to do numbers 15 to 53 odd plus number 54. Please make sure to ask if you have any questions at all, and I will see you tomorrow.